Sorry, can you hear me?
Yes, I can.
Okay. Yeah, I'm going to turn my camera
everybody.
off just because it was
Okay.
slow connection.
Okay, we're starting the webinar. Welcome, everybody. Thank you for joining us today. My name is Jennifer Griffith, and I work at NMOA, which is the Northeast Waste Management Officials Association. I'm showing the NMOA website. Is that what you're seeing, Megan? Yes. Okay, great. So welcome everybody today. I've got the website up so that we, well, we got some feedback here. Let's see if I can fix that. Sorry, folks. Okay, sorry, let's start again. So I'm showing the NMOA website so people can get a better understanding of what NMOA is. If you don't already know about NMOA, we are the Northeast Waste Management Officials Association, which is an interstate association of the 6 New England states, New York and New Jersey. We were formed by the governors back in the 1980s to focus on waste issues. So solid waste issues, hazardous waste issues, pollution prevention and toxic use reduction, as well as the waste site cleanup program. And that's what I manage at NMOA, the waste site cleanup program. And this webinar originated from that group because a lot of contaminated properties, when they're being redeveloped or cleaned up, require the removal of some buildings and structures. And so we've got this sort of intersection with the solid waste world in that regard. And we have continuing challenges for disposal capacity in our region here in the Northeast. So the thought about deconstruction and waste minimization and materials recovery was of interest to folks. So we developed this webinar. We've got 3 great presenters today. We're going to have Megan Mansfield-Pryor from the Maine speak about what deconstruction is and why it's important. We've got Daniel Salomon, who's going to be sharing his experience with deconstruction. And then we've got Dan Costello, who owns a large demolition firm, talking about his experience, and he'll be presenting 2 case studies. So just a couple logistical things. We've got a lot of people joining us today, which is great. So, but we're going to have to handle questions via the question section. So in your control panel there is a section for questions, and you'll just need to type questions in. Then I will be monitoring those, and I will ask questions during the question time. So just type in questions at any point. You don't need to wait until it's the official question time. So I'm also showing them on our website because I want to show folks where you'll be able to find this presentation afterwards. So yeah, we have a little bit of an echo here, but there, if you go to NMOA programs, we have waste site cleanup, and then there's training. And then you can scroll down, and yeah, we're gonna have to see somebody. I'm gonna have to mute Dan here. So, but Dan, you did come on, so that's good. But I had to mute you so we don't have the feedback. So anyway, here's some workshops that are coming up that NMOA is organizing. In-person workshops, day long, if you can attend those. And then also we've got the non-PFAS webinars here, and this is where this webinar will go after it's finished. We're going to be posting PDFs of the presentations afterwards. Here, I'll show you the last webinar that we did. So we've got the presentation slides and then also the recording. So that will be here later. You can also, on the NMOA website, go to events and find this as well, the same information. It will be, here's today's webinar, which is, so it's very forward focusing, the events section. It's things that are coming up. Here's all those in-person workshops. But then if you click on this little back button, you really got to know about this back button here. Then it will give you things that happened in the past. And so you can look through all the different public webinars that we've had in the past. Lots and lots of them on PFAS that I did back in the fall. So, and here's that webinar that happened a couple weeks ago. So with that, I think we'll get going here with the actual webinar for today. So again, I'm going to introduce the first two presenters are kind of going in tandem. So I will, I forgot to ask, are we going to do questions between your presentations or just after Danny's done? What do you think?
I don't have a preference. Danny, do you care?
Nope, I don't care. Whichever works.
I'm going to introduce both of them then, and we'll just sort of hold questions about the deconstruction topic and experience until they're finished. And then I'll introduce Dan before he starts presenting. So we've got Megan Mansfield-Pryor, who's up on the screen there. She's a waste management climate policy advisor with the Governor's Office of Policy Innovation and the Future in Maine. Megan has staffed the Materials Management Task Force of the Maine Climate Council, which brought solid waste management strategies to Maine, into the Maine Won't Wait 2024, the state's 4-year climate action plan. Prior to joining the Governor's Office of Policy Innovation and the Future, Megan was an environmental specialist with the Maine Department of Environmental Protection, where she oversaw several product stewardship programs and provided outreach, education, and technical assistance to municipalities and businesses to meet specific situational needs for waste reduction and recycling efforts. So, and I've worked with Megan many times in the past, and she's a great asset to the state of Maine. And then we've got going to be followed with Danny Salomon, who's the founder and principal of Second Story Builders, an emerging mission-driven business in the Mid-Coast, Maine. He's committed to reducing construction waste by offering deconstruction services, reclaimed material sales, and design-build project delivery that prioritizes the use of salvage. Danny also serves on the Historic Resources Committee in Camden, Maine, and previously ran a community-oriented design-build program at the Camden Hills Regional High School, which is called the Hatchery, and it exclusively sourced materials from the region's waste stream. So I'm going to turn controls over to Megan, and we're going to all mute ourselves except for Megan and turn our cameras off. So thank you, everybody.
Great, thank you, Jennifer. I'm trying to pull my presentation up. May I ask what it's showing at the moment? Because I'm not seeing. Hold on, there we go, I think.
Actually, I'm seeing your email and everything, your inbox.
Ah,
So
now you see the slide?
Yeah, there we go.
Okay. And I'm going to turn my camera off just to save bandwidth while I run through the presentation.
I turned it off for you, but.
Oh, you did. Thank you. Okay, so well, Jennifer had already introduced me, so I work for the Governor's Office of Policy Innovation and the Future. An easy way to say that is GOPIF, and that's the acronym we use. Oh, hold on one second. So I'm a waste management climate policy advisor, and I'm work in the Governor's Office, but I'm also sort of a shared employee still with the Maine Department of Environmental Protection, so I work closely with them still. And as Jennifer mentioned, I staffed a temporary task force that was part of the Climate Council and formed specifically to bring materials management into our climate plan. We also have 6 sector-specific working groups and 2 subcommittees that help ensure that we're looking at climate change from all different angles, and we're thinking about equity, and we're basing decisions on the most recent scientific and technical data. We have statutory goals to reduce our territorial emissions, and we are making progress on that. A lot of the emissions that we're going to talk about today, though, are really more embodied emissions from saving building materials. So I'll get into that a bit too. Our 4 primary goals are to reduce greenhouse gas emissions, become more resilient, create jobs and economic prosperity, and make sure that we have that equity lens in everything we do. So we're suggesting climate action that's accessible for everyone. These are the high-level strategies in our climate plan. And again, I'm only going to talk about the ones that have building materials baked in, but this is how our plan is organized at a high level. And there's a link at the end of my presentation to the actual climate plan if anyone is interested in seeing that. So these are the specific recommendations that get into deconstruction. One of our high-level recommendations is to promote the use and manufacture of climate-friendly building products. And this is being recognized, well, there hasn't been a ton of action yet, it's being recognized federally and at a lot of local and state levels that when you reuse building materials, you're really reducing that embodied carbon. So we recommended encouraging municipalities to start encouraging salvage by posting a public 2-week notice that gives people time to get in and salvage, along with liability language that would reduce risk of liability to the property owner and the municipality for allowing people to get into a property that's slated for deconstruction and salvage what they can from there. We also have a lofty goal to require large commercial and state-funded buildings to be designed for deconstruction and reuse by 2030, and that's part of our Lead by Example initiative across state government, where we're trying to set good examples in everything we do. And one reason for that recommendation is that, as you can see with the statistic here, there's a lot of embodied carbon in the built environment that can be reduced if you plan ahead and you're designing buildings better so that the materials are ready to be reused, less glue, and more things that can be undone and more flexible uses for future repurposing. So the federal government, there hasn't been a lot of recognition of salvage and reuse as low embodied carbon materials. And it hasn't really been institutionalized in procurement yet, but there's a lot more attention, or there has been in past years, recent past years, about the potential to reduce carbon emissions and also keep more manufacturing and supply chain in the country. So the Department of Energy's React Before Recycling program was looking at keeping products and components in use longer. The GSA Facility Standards for Public Building is also looking at deconstruction, and the DoD is also considering how they can reduce embodied carbon. A lot of this comes down to materials reuse or recovery. And then, as I mentioned, we are not only do we have that goal in our climate plan, but we're part of the federal state level Buy Clean partnership with the U.S. Climate Alliance, where we make a commitment to try to procure building and construction materials that are made with lower carbon, which includes salvage materials. So construction and demolition, if you don't already know, they're a huge source of our global emissions and also a huge source of our global waste. And if we were really focused on deconstruction, we also have the potential to reclaim huge amounts of lumber for building new homes, which, as anybody who's in the housing sector or has looked for a house knows that we have a real shortage of housing, especially affordable housing right now. So deconstruction presents a huge economic opportunity as well as a source for materials for affordable housing. So as I mentioned, in Maine, we have territorial emissions goals to reduce our emissions. And when you look at that from the in-state perspective, you can see waste is just a really small part of our emissions. It's like about 2%. But if you take a step back and you look at emissions from a global perspective and you think about emissions across the supply chain of stuff, then we see that materials management, which is like from the point of extracting resources to make products that we use, to the point where we dispose of them, it's a huge portion of our emissions is stuff and materials, and buildings are a big part of that. Resource extraction has tripled over the past 50 years, and there's scientific consensus that this has been a big contributor to climate change, biodiversity loss, and pollution, which means also that materials management represents a huge opportunity to reduce those impacts by using things more efficiently. So any kind of practice that preserves materials is going to reduce those consumption-based emissions. And here in Maine, we're doing great with reducing our sector-based emissions. Plus, we're a heavily forested state, so a lot of our emissions are already sequestered through our natural environment, which means we're really close to total carbon neutrality for in-state emissions. And the farther that we get as a state and other states and governments that are doing the same thing, trying to reduce their emissions, the more important those embodied emissions or those consumption-based emissions are going to be, because we're going to have the in-state emissions gain. So then we start thinking about our supply chain or our scope 3 emissions. And buildings materials, there's a huge opportunity to reuse. Most of the debris that comes from construction and demolition is demolition. Only about 10% of it comes from scrap. And you can see that even just here in Maine, we're a small state, less than 1,500,000 or 1.5 million people in our state, and we produced over 600,000 tons of demo debris in the last year we have data for, which was 2022, and only about 2% of that made it out of a landfill. So just a little snapshot here in the blue box. This is modeling that was done with the EPA's waste reduction model. So you can see that reusing just 50,000 tons of wood, which is a very small piece of that overall tonnage, has an emissions reduction equivalent to taking almost 30,000 gas-powered passenger vehicles off the road for an entire year. Plus, you get really quality materials when you salvage, like heritage timber from old growth lumber that you just can't find anywhere else. So there's a lot of benefits there. Just some terms to know about deconstruction. Demolition, as you almost certainly already know, is just tearing stuff down. Deconstruction is when you carefully disassemble and then you try to extract maximum value from anything that can be salvaged for reuse or refurbishing. Depending on the case and the building, there's a soft strip where you might go in and just take the really high value stuff, or there's a whole home. And I know that we're here talking about brownfields, so think whole building instead in this case where feasible, which is really when you take everything apart and you're getting down to the structural elements and trying to recover as much as possible. And then embodied carbon, I already talked about, that's the greenhouse gas emissions that occur from production, transportation, and extraction. So in most cases, territories like states or local governments aren't counting those emissions because they're not part of their territorial or sector-based emissions. There's also a huge amount of workforce development opportunity. There was a study on the circular economy just looking generally at reuse and refurbishing, and the job creation potential is massive at 300 jobs per every 10,000 tons of waste compared to only 1 to 6 jobs for disposal pathways like landfilling and incineration. They also found that a lot of the circular jobs had better working conditions, higher pay, and there's the opportunity to bring back some historic skills, like this campaign for historic trades is linking deconstruction and some of those traditional skill building trades along with construction, learning how to reuse and refurbish and build things from scratch. So when you pair those construction with deconstruction skills, you really get a workforce that's capable of a lot more, and it opens up new economic pathways for different jobs. There's also community resilience here. Communities where they have refurbishing warehouses kind of give a sense of place, and you can bring people in from the community to learn skills. That would be obviously different from like a business environment, but in some cases there's entities like the Finger Lakes Reuse Warehouse, which is more of like a community organization, but they're still teaching skills and they're still turning out workers who have grown as a result of being involved. There's also been some examples of public-private partnerships, like in Phoenix, they started a reuse hub, and it resulted in 19 companies that were launched, 14 patents, and 15 products over the course of 6 years. And then to get to brownfields specifically, the approach to brownfields has really been evolving in recent years. So they're looking at it now. This is all taken from EPA or the C40's Climate Leadership Group, but really thinking about redevelopment from the triple bottom line approach. So a more sustainable development where you're thinking not just about the environmental concerns, but also the community and the economy. So we know that when we're landfilling a lot of waste, that's a loss of material that could have been used in our economy. And deconstruction, as we already mentioned, it creates jobs, spurs innovation, and it preserves local character and heritage with some of those materials you just can't find anymore. There's also a lot of resources for assessing the potential for deconstruction at brownfields. In 2024, EPA awarded 14 communities with grants specifically to train under and unemployed individuals with skills to seek long-term employment. They also have a lot of resources that can be used to assess the potential, whether a site's actually a good fit for deconstruction, and also trying to value the materials there to know, what might be worth saving, what might not be, and a rapid assessment tool that kind of gets you through all of that in a more concise fashion. So these are great tools. These are all linked to in my presentation, and I'll share this out so you have the links to all of this stuff. They also have the Greener Cleanups Initiative, which is looking at material reuse and deconstruction, and looking at the workforce potential there. And the Army Corps of Engineers, this is a little bit of an older document, but it's a really good resource. They have a Market Smart Deconstruction and Material Recovery at Brownfield Sites guides that's just packed with good information, and is a really useful tool for anytime you're trying to assess a site. And then just a little bit more on that particular study, just to get the high level idea of what's in there, noting that in many cases, deconstruction, whether or not it's going to be applied at a site, is a ranking criterion. So if you're applying for a grant, for example, it would make you more competitive to work in aspects of deconstruction or material reuse. They're going to want to see that in the grant application. Saves money, resources, job training, and it also has the potential to earn LEED credits for a site. Not to mention, as they say, it's just also the right thing to do. And there's also guidance in that guide on dealing with things like lead paint, asbestos, and other kind of contaminants that we find in a lot of these older buildings, and particularly brownfield sites. So just again, the triple bottom line of deconstruction, there's social benefits. In many cases, where some of these brownfields are being demolished, there are communities that are impacted by these, and the demolition tends to take place in communities, lower income communities, communities of color have been disproportionately impacted, and the contaminants from site demolition can end up contaminating the air, contaminating the water. So again, another reason why deconstruction is really a safer way to go. A huge amount of economic benefit. A study out of New York found that shifting to building deconstruction from demolition would really reshape an entire sector of their economy in a positive way. And then obviously we talked about the lower embodied carbon for these materials really is a huge benefit. Even just a regular little single family house has about 40 tons of embodied carbon. So something to think about. Just on any level, a bigger building obviously has even more of that. Another great resource for considering deconstruction is the C40, and the link to the website's in the slide here. But there's a lot of communities across the globe that are considering deconstruction policies, and it doesn't have to be a mandate. There's a lot of different ways that people can go about it, whether that's looking at wrapping it into comprehensive planning, or calling together a wide range of different stakeholders who have an interest in the topic and trying to come up with some ideas of how it might work in your community. Thinking about municipal procurement for salvage materials, or partnering with organizations like those involved with historic preservation are typically good partners. And it's also really important to have marketplace development for the reused materials to ensure that you've got a place to, you've got an end market for the materials once they're salvaged. So just a snapshot, deconstruction is in our climate plan in Maine now, and there are a lot of other, mostly municipalities, but there is one other state that has a climate plan, and you're seeing a lot more awareness of deconstruction potential in municipalities that have passed deconstruction ordinances. And these aren't all mandates. Some of them look different. Some of them might be tax credits, so everyone is unique to the community where they're passed. And then the biggest barrier, of course, is just low cost disposal. But with deconstruction, there are other costs that are not factored in. So, oops, sorry, let me go back to that. When you're looking at demolition, it's just one lump cost, but with deconstruction, there's also economic benefit from the materials that are salvaged. So it's important to think about it in that long-term perspective over the cost of a job rather than just the upfront fee. This is just a great quote. We recycle bottles, but throw away our houses. It's so true. It's such a massive waste stream, and it'd be great to see more recovery of those materials. And I think I'm running out of time, so I am gonna pass it off to Danny to make sure that I don't overtake too much of his time. So I'm gonna stop sharing. Thank you, Jennifer. You want to pass it?
Great. Well, thank you, Megan. And I'm going to make Danny the panelist, make him the presenter. So, great. We see your slides, so perfect. Oh, just got to unmute yourself.
Oh, okay.
Oh,
Hello.
yeah.
Is it
good.
up? Are we good?
Yeah.
Can you hear me?
You're good.
Perfect. Okay. So hello, everyone. My name is Danny Salomon. So I'm going to sort of show what Megan was talking about, how it looks like on the ground. I've done a lot of work sort of in the area of deconstruction and reuse over the past decade and a half. And like Jennifer mentioned, I've recently started a company to really pursue this full time and to really take it to the next level. But we're going to go back in time to when I was a college student, just coming out of college. I studied architecture at Cornell University. So I started to, during my thesis semester, really kind of start to think about what happens with buildings at the end of their life cycle. The university, there we go. The university actually hired me right after I graduated to work in the material practice facility at the university, which was basically a shop that had both traditional equipment as well as some digital fabrication equipment. And at the time, the university was investing a lot of money in putting together a new studio space for the architecture students. So it's this building in the middle here, Milstein Hall, attaching some of the older structures, and they thought, you know, this would revolutionize the school and have a huge impact, which, you know, to some degree it did. So it was connecting these two buildings here. The older building on the right was where the studios used to be, sort of like an old brick factory. But what I experienced was, in sort of shifting all of the studios out of that former space into the new studio, it allowed the shop to expand considerably in that old building, and that had a much more transformational sort of impact on the architecture program, art program, and the planning program, which the shop served. So there was enormous opportunity for students to start to learn a little bit more about the hands-on processes in building, which is, I think, really important for architects to be learning. So I helped, students, assisted them with all these different complex projects, building models and things like this. We built practical things as well, canoe paddles and other models and things. But one of my takeaways from that job, I worked there for 5 years, was that we had a dumpster outside, and right after the projects were over, students would often be throwing out their models that they spent, you know, hours slaving away on, all-nighters and all of that. And I just thought, couldn't there be a better way? Could we be thinking proactively about what these things could become afterwards? So again, there was sort of this revival of hands-on practices with the shop. There was not as much thoughtfulness about where materials would go. So in my last year working at Cornell, I helped co-found a student organization called Building Community, where students from any department could join and work on community-based design build projects. And so we started to partner with some of the local reuse facilities. There were 2 significant elements and Ithaca Reuse. We worked with here a 4-H program, building benches and kind of teaching them how to use basic hand tools. We also worked with Hammerstone Builders. This was a sort of women-led building project, reviving old sort of shops like typography, putting together sort of dinners and supper clubs, and we built all of the tables for those and got people involved. And then the biggest project that we did there was building what we call the traveling tool library to make tools available to the public. And this project, we used entirely salvaged materials from some of those stores that I mentioned before, as a way to kind of learn how to work with older lumber that might have defects that are certainly workable back into newer projects. And so this project was not only a tool library, but it also became sort of a stage set for performances, and it still is out in Ithaca being used for a variety of things. My first intersection with deconstruction and a reuse business was in Buffalo, New York. I started working with a fellow out there and his business Reuse Action. It's this fellow here, Michael Gaynor. So he landed in Buffalo. He used to live in the Boston area, but moved to Buffalo, and was there when the mayor instituted a fast track demolition program, which a lot of mayors in Rust Belt cities did sort of around that time, like the early 2000s. And he was just kind of calculating in his head how much like taxpayer money essentially was being used to clear away what were deemed, abandoned buildings and sort of hazards to the city, when people across the street needed to repair their buildings and their homes, couldn't maybe even afford materials from stores, and also were looking for employment. And he sort of connected the dots and realized there's something here we can do better. So he founded Reuse Action. I did a little bit of work with him. So again, he started with trying to intercept a lot of these homes that were slated for demolition by the mayor, but I also worked with him on just this example here, saving an entire gym floor. We actually did 6 of these at different public schools, and this was, one thing I think that people don't really think about in terms of deconstruction is that demolition is fairly straightforward. It's just like how quickly can you get this material and crush it and get it in a dumpster and remove it, right? Deconstruction has a lot of innovative potential. And so the way that a gym floor would normally be demolished is you would go in there, maybe a crew of like 4 or 5 people, you'd cut sections of the floor as small or as big as you can where you could still pick it up, and then you'd walk it out to a dumpster and throw it in. And I actually witnessed this when I was working at Camden Hills Regional High School here in Maine. Later on, we had to have our gym floor replaced because of water damage. And it took about, I don't know, a crew of 4 or 5 people over a week to do that. Whereas Michael, myself, and one other person shown here in the image were able to save this entire floor in just a day and a half. With a forklift, we just snapped lines, cut the pieces into sections, 4 by 16 foot, palletized it, and then the trickiest part was just kind of getting it out the door. But this shows that deconstruction can actually, in certain cases, even be more efficient because you're really thinking thoughtfully about what you have to do and how you can make all of this stuff sort of available to the marketplace again. Another intersection with reuse that's a little bit different that I got to be a part of in Buffalo as well was Assembly House. This was a program founded by this fellow here, Dennis Marr, who is an artist and an architect in Buffalo. He actually also studied architecture at Cornell University before moving to Buffalo. So he was a huge mentor for me as I was kind of getting going on my career path. His work actually started with when he moved to Buffalo. He was doing demolition at night, and he was teaching at the school, or like in the evenings, and teaching at the school during the days. And one of the things that he started to do was make art installations in some of these demo projects, kind of like moving materials around, making these installations, photographing them, and then putting everything back before the rest of the crew arrived in the morning. This sort of obsession with material waste kind of led to his art practice. So he does everything from sort of large scale sculptures to wall pieces like you see here. And today he's now doing all kinds of architectural interiors and things that, again, are just kind of using things from the waste stream in Buffalo. He loves to go to estate sales like religiously and pick away things that people see very little value in and make them come alive again. So in this church, which I showed before, it was an abandoned church that he was able to obtain for basically the price of a car. There are a lot of abandoned churches in Buffalo. There's amazing architecture in Buffalo, a lot of which has been abandoned. And so this is what the sanctuary looked like when I arrived, but his idea for this church was to turn it into a really unique workforce development program that intersected with both folks in architecture and in the arts. So we turned a lot of the materials that we found in this church, like the pews, into work benches and work tables and sawhorses, and cleaned up the sanctuary into the wood shop, bringing in all sorts of experts in furniture making. And there's me working with one of my students on a huge frame that he wanted to make. So this program is still running. It's developed a lot since then, but just another sort of example of how deconstruction can go so much further past just waste diversion, but it's also an amazing opportunity for education and workforce development. I then moved to Chicago, where I worked for a bit at a nonprofit called Sweetwater Foundation. Sweetwater is located on the south side of Chicago in a neighborhood that's been also the target of fast-track demolition under Mayor Emanuel, Rahm Emanuel. And Emmanuel Pratt, shown here with me, is the executive director, a really brilliant human being, super creative, again, with a background in architecture and urban design and urban planning. And here's some Sanborn maps that just kind of show you the area, which used to be highly populated, but as you can see, in 2012, when Sweetwater was started, so many of those buildings, those homes that you see in the image on the left, had been demolished as part of, again, this fast track demolition initiative instituted by the mayor. So what do you do with all of this vacancy? So Sweetwater has started to sort of rebuild the neighborhood with folks who have stuck it out and who still live there, and also bringing in folks like myself from outside to kind of help be part of that network. So they did the first, you can see on the bottom there, the Thought Barn is in the middle of an entire city block. It's the first timber frame barn structure raised in the city of Chicago since the Great Fire. This is a community space, and surrounding it is a community farm, because this area is technically also a food desert. So food is a huge part in growing food of what Sweetwater does. And a central principle at Sweetwater Foundation is transforming waste to resources. So all of the building projects that we did, we almost exclusively source materials from the region's waste stream, often higher grade pallets that we're shipping, say like large expensive glass to do new construction downtown. We would intercept those, take those pallets apart, and turn them into, say, raised beds. This is the community garden, open to the public at all times. Also on the farm, intersecting with a lot of local schools, public schools, so they can do outdoor education. And then there was also, and this was something that I sort of specialized in, a carpentry apprenticeship program for youth, which we built just sort of out of a greenhouse space so we can kind of keep it heated, and just use sunlight to keep it heated even during the winter. And just using what we had, being really resourceful, cleaning up, and turning it into sort of like a curriculum, how to take old 2x4s and turn them into all sorts of furniture projects and other things. These are called fractals, and we would sell these also, and a lot of people in the area like to buy them and support what we did. And then lastly here, I just want to show, so this is a common site on the south side of Chicago, just a lot of vacancy. So we were able to turn this vacant lot into where we would have our market. So we would have Friday markets, and people could sell their crafts. Again, everything you're seeing here, including the space we call the meeting house, was made using 2x4s and other wood that we salvaged from pallets. Its surface was charred to help preserve the wood. It's a Japanese technique called shosugiban. But even during COVID, we were able to use this space. This here is a local chef who did a live stream cooking lesson from the space and community meetings and so forth. And yet, just a few blocks away, we would still see sort of what status quo demolition looks like. This was a common site all the time. So now skipping ahead to how I landed in Maine, I arrived here. I came directly from Chicago and was hired to launch a program at a local high school called the Hatchery, which was sort of an innovation program that was reviving the old industrial arts wing, which is what we're sort of looking at the outside of here. It was sort of a mess when I arrived. There was materials everywhere outside. The tools were all kind of all over the place. But having just come from Sweetwater and seeing what transforming waste to resources looks like, I saw the amazing potential in all of this. So there were a bunch of pallets, so I thought we would start with that. And I rebranded Transforming Waste to Resources, which was Sweetwater's tagline, to Radical Reuse. So this program, I instituted this principle, the idea that we would only source materials from the region's waste stream, from our region's waste stream, to do educational projects with students with some sort of community benefit. So collected a bunch of pallets from local hardware stores and things like this, and just pallets that were around the school. This program started when COVID was still, something we had to be sensitive about. So there was a mask mandate when we were indoors, but students could take their masks off outside. So I hosted outside what we called Pallet Palooza, which was like a pallet deconstructing party, just to kind of introduce myself and to students to the idea of salvaging materials. I didn't know how this would go, but students were really into it. There's actually a lot of technique involved in taking pallets apart successfully without breaking the wood. So they got to learn how to swing a hammer and use a pry bar properly. And then skipping ahead to 3 years later, once the program had sort of done all these projects in the community, it had gained a reputation for this idea of radical reuse. There were folks asking about, well, could you deconstruct, this house or this building in town? And so I thought this house that we're seeing here was a good opportunity to try that. So we did this last winter. This was a house right in Camden, built in 1890. And it was a good candidate for deconstruction because it had been vacant for 40 years and there was no insulation in the walls, surprisingly. There was no asbestos present, so a lot of the hazards that normally come up for projects like this, we didn't have to deal with. There was lead paint. So when we started with the siding, we just tried to contain the lead paint as much as possible, no cutting, just kind of prying it off. In places where deconstruction is a little bit more kind of advanced, like in Portland, Oregon, for example, which Megan mentioned, even these materials often get saved and repurposed. But just to minimize hazards, this was one thing that we decided to just kind of remove and dumpster. We took the plaster down next. A bunch of students and some of my friends were involved in that. Again, there's like innovative ways of doing this sort of quickly and smartly. So, plaster is incredibly heavy and messy, but rather than try to bag all of that ourselves and carry it out the door, there was a site worker that was going to come in and redo the foundation. There was a new structure going up there. So we communicated with him that we would put these bulk bags in the basement and just kind of sweep everything into those, and it made it much easier to deal with. And then he could pick those up and deal with them when he had a machine present. We saved a lot of the lath too, which I'll show you later what that can turn into. And then using techniques that I learned from my friend Michael in Buffalo to kind of get off the site quickly and not hold up the contractors, we cut the house into sections and used the boom lift to bring everything to the ground so we could deconstruct it off-site at a later date and not have to slow anything down. So there you go. That was the house.
Just got a couple more minutes. So just,
okay,
yeah,
yep.
one or 2 minutes.
Almost there. Okay, thank you. Everything that that I couldn't personally use, or with the students, like the windows and doors, we had no use for those, got donated to Habitat Restore. So there's opportunities to create partnerships with folks who are already doing this work. And slowly over time, as we needed materials, we would, bring these sections over to the school, denail them, and we had a whole stockpile of materials to do all sorts of different projects. I worked with a lot of hockey students and they needed a stick rack for their locker rooms. So this is the stick rack using lath and some of those sheathing boards from the house. This is for the ceramics class, a table that helps recycle used clay with like a plaster slab to extract moisture from the clay. Ice fishing shack, tables, guitars, all sorts of things. Even working with the middle school and doing some projects, some benches outdoors. And yeah, a bunch of musical instruments as well, and even some performances. So another benefit of doing deconstruction is, we lose a lot of our history when we take older homes down. And Knox County, I think, has some of the oldest housing stock out of any county in Maine. And so as we were taking the house down, this is on the back of the siding, we saw all these old companies that used to exist. And even in the walls, I found some film and got it digitally scanned. And it was all these images from, I believe, the Korean War. I'm still sort of unpacking the history of this house, but all this stuff would have been lost had had we not deconstructed it. So yeah, again today I've started a business, sort of bringing this whole idea of radical reuse forward to the next level. I started a company called Second Story Builders. I've been continuing to work with students and with youth on a project right here in Camden. There's a cafe that's going to be open in April, and we're using a lot of the materials from this house. Here's some of the lath to do some of the work on the interior. So this is just one example of what you can do with lath, kind of clean it up, just skim plane it, and we're using it to make wainscoting in the new cafe. And I have a few deconstruction projects lined up for the next few months. So anyway, if you're interested in learning more, please feel free to reach out, or if you have deconstruction work, I'd love to help give you some advice on that. So I'll end it there. Thank you.
Great. Well, thank you both, Megan and Danny, for all that. Megan had a lot of information that she went through quickly, and her slides and all those links will be available afterwards. And then Danny, a lot of those organizations and projects, they can maybe be the outcome of some brownfields redevelopment. So keep those kind of things in mind. I thought those were really interesting. So our next presenter is going to be Dan Costello, and he is, let's see, I'm gonna unmute him.
There I am.
Yeah,
can you hear
there
me?
you are. We need your slides. Yes, I can hear you. Yep, we need you to something should have popped up on your screen that you need to accept, and then you can show your slides.
Okay. I think I just pressed it.
There's your email. We're seeing your email. So sorry, everybody. We did practice this a couple weeks ago, but so hopefully Dan can get his slides.
Show screen.
Yep, we're seeing your email though. So you need to put your presentation there instead.
Honestly, I don't know how to do that.
Oh, okay.
I thought you had it. I thought that Leslie in my office had sent it to you.
Well, she did, so I can call it up here. Yeah, hang on, everybody. It'll just take me a little bit of time to get it. Let's see, where is it? It is a big file. Okay, so I will show my screen then instead. And then Daniel just have to tell me when to move the slides. So sorry, everybody. Let's see.
Jennifer, and thank you.
Okay, wait a minute. I got to introduce you. Hang on a sec.
Okay.
So I'm just trying to get it ready here so that it works. Right. Okay. So Dan Costello is the founder and president of Costello Dismantling Company. He's serving the demolition, dismantling, and recycling needs of commercial, industrial, and municipal clients since 1985. Dan maintains close professional contact with the industry through active participation as former board of directors member of the National Demolition Association and also the Construction Material Recycling Association, and in many local professional associations, including the Environmental Business Council of New England. So with that, there we go.
Great.
Take it away, Dan.
Jennifer. As the title of this presentation points out, every demolition job is different. Jennifer's invitation came about as a response to a couple of project studies that I have presented recently that both show demolition jobs of major facilities and highlight the capabilities of Costello Dismantling. And we certainly, one of the interesting things that guides us is our mission statement, which is to continue as a leader in the dismantling industry through embracing a culture of innovation, safety, integrity, and respect for our employees, clients, in the environment. So obviously through that and 40 years of experience in the marketplace, we're called upon by a wide variety of owners and clients to do a wide variety of projects. Some of them, wide range. I mean, it could be a part of a chemical or a pharmaceutical plant coming down to, we do a lot of tank work. We do a lot of municipal and industrial building work. One of the things that drives us is we have a fleet of equipment that's highly adaptable to all these situations. And we're a fully licensed asbestos contractor and hazardous material contractor in all the New England states. Jennifer, if you would. Recently, some of the types of projects we've done show the variety of work, from an elevated water tower in Reading, Massachusetts, to a stack demolition in Plymouth at Plymouth Cordage Company, dismantling of a wind turbine that is becoming an increasingly popular job these days. There are a lot of wind turbines that are approaching the end of their life, having been installed 20 years ago, and now they're being replaced. As is, you see an example of some of the development we do for, the bottom left shows Arlington High School coming down. And we're providing the footprint in this case for the brand new high school, which is being built. Actually, about a year later from that picture, we are on site with the final phase of Arlington High School demolition, but the transformation is quite incredible, as is the other transformation that you see on the right-hand side, which is a power plant that existed from the early 1900s, about the 1915 vintage, a coal-fired power plant that was built in New Bedford, Massachusetts, is now the home base for the offshore maintenance for the offshore turbines and wind industry. It will be the maintenance center for the next 30 years for that new industry. Again, born out of the footprint of an existing building. Jennifer, if you would, we're going to show two typical projects in our sense that had slightly different, or not sort of dramatically different procedural impact, how we conducted the work, and the end result of recycling in each case. So Jennifer, the first project we'll look at is an area of Boston, the seaport, where we were engaged to take down two buildings, 22 and 24 Dry Dock Ave, for a local developer. And we set about this very intentionally from the beginning. Jennifer, if you could flip forward. We evaluate every building and every work site, always looking for salvage and recycling and reuse opportunities in certainly the construction of the buildings that we deal with that are most important, and the recoverability and recyclability of those integral building materials. We rely heavily on source separation of materials so that we can streamline the end disposal facilities or processing facilities where material goes, rather than rely on bulk commingling of material. In order to do that, you need a great plan. You need to have sufficient space to do it. We need the cooperation in every case of the owners or the contractors for whom we're working, because these projects are usually part of a subsequent to following up new construction work that is tied to very tight timeframes. So we need to be able to satisfy the customer's time frame and work within the space requirements to source, separate, recycle, and recover material. Jennifer? This particular building was quite interesting. It was part of a LEED Platinum project for the build out of a new bioscience lab in the seaport. This building was a Navy building dating back to the dates of the Boston Navy Yard. It was built in 1922. And part of the LEED Platinum project was the salvage and recovery of architectural artifacts. So we took out a very nice Art Deco carved sign that announced the Public Works Department of the Navy Yard in Boston. And that granite edifice, if you will, was going to be implanted in the brand new LEED Platinum building. Just an interesting recovery. The building itself, we recognized immediately of having great potential for salvage and recovery of, in this case, heavy timber framing. We've developed over the years a fleet of equipment with specialized attachments on, in this case, you see one of our high reach excavators with a 360-degree rotating grapple that allows us to very, very precisely grab hold of and dismantle structures like these timbers from a building without damage, and allowing very careful deconstruction of the building. And relating back to our general strategy, we have this fleet of equipment that's very versatile and multi-purposed and can be used on a number of types of projects. Okay, Jennifer. The planning for this, as we saw in all the other presentations ahead of us, Danny, in your work, and Megan, in yours, you need a plan, and you need to have space and the ability to handle materials so that it can be salvaged and reused. In this case, in the building of the lower right, where Jennifer has the cursor, that was the adjacent building to the one with the timbers. And it was all made of concrete and brick. So after asbestos abatement and hazmat recovery in that building, we designated that as the workspace, the storage area for the material to come out of 2024 dry dock, which is the building on the left that had the substantial recovery. So we utilized our time and space and created a great staging area for the material coming out of our building. So here we see the different components laid down on the slab that was created, recovery of timbers, heavy decking. And again, our general safety plan calls for this work being done mechanically rather than manually. We feel in our work and our safety experience reveals that we don't want to put people in the potential danger of dismantling or disassembling these large timbers, portions of the structure by hand or in close contact. So we do that mechanically, and we have very, very few laborers on a job site. Most of it, we have small skid, we have large machines and small skid steers to move material around, and we're able to have very, very substantial recovery because of our techniques and because of the material that we're trying to salvage. If it becomes much smaller than that, it becomes very difficult for us to handle, and frankly, we don't have the outlets for the end product. Again, we're looking to source separate material. We're continually separating material and shipping it off-site by waste designation areas, where it goes, where it can be recycled, or where we have to go for disposal or processing. And in this case, we have 1, 2, 3, 4, 5, 6 plus grades of material that would derive from this one project and in this one building, all going to different disposal facilities or different processing facilities. So we sort like that because it makes the site organized and safe to walk around, but also we have less disposal costs by being more particular about the materials we go and bringing it to facilities that specialize in reuse of that material. Okay, Jennifer. Here we are with some of the timbers that were recovered from this building. We knew that it was built in the early 1920s. It was a government building, and we could tell by looking at the wood that it wasn't southern yellow pine. That's the sort of the ultimate goal of looking for heavy salvage timbers, but this was Douglas fir, and we knew going in that it probably was Douglas fir because of the time frame of the building in the early 20s, at which time yellow pine would have been used up. And on a government building, they would attract material from, particularly in that point, the Pacific Northwest, where the Doug fir would come from. So we had 100-year-old timbers that, although given the size of them, they're still quite fragile and delicate. And we handled them gingerly on the job site and bundled them, strapped them for transport, loaded them in economic loads weight-wise to fit on a trailer. And we shipped it off to a local, we'll follow it to a local sawmill. This is a company that we've done business with for decades. They're a fixture they're in Katomet on Cape Cod, Massachusetts. They have a facility of, first, on the left-hand side, you see the received material. Then each piece goes through a very rigorous process of denailing and moving any metals and sorting the wood for different saw grades. It's extremely important that, in tedious work, to get any any wood, any metal out of the wood, because you're going through saws and planers and, you know, a bolt hitting up against a saw blade isn't a good situation. Not good for the wood and not good for the saw blade. So that sorting is very important. We saw the different gradings that took place with tabletops, wood flooring, and we even had some structural timbers that were derived from that material. Okay, Jennifer. We maintain a waste management plan and present to the owner of the project the different outlets for material that we used. So in this case, we had over 5,000 tons of material that was derived from the building, and we highlighted the asbestos and the hazmat portion of that, but the rest of it, we show the recycling percentages, and we did some interesting thing. One of them, we had a high wood content. So those items, say the non-timber or non-heavy structural items of wood that came out of the building, there was still an awful lot of wood flooring and wood partitions in there that we separated, and we sent it to a processing facility that has a biomass fuel contract, and we were able to get very favorable prices because it was extremely clean wood that was eligible for biofuels. So we took a lot of attention in each of those different end markets, if you will, for all the material, and came up with a very high recycling rate. Okay, Jennifer. That's one project, and that highlighted a lot of good salvage and recycling, because that's the bones of the building that we had to take down. We're always, we'll go into another project, a Brownfields project, that on the outside you'd say looks similar, similar vintage, similar, you know, brick exterior, but a building that had very serious contamination issues. And this was the Armory in the city of St. Johnsbury, Vermont, that we were engaged for the demolition of this. We knew early on through this was a part of this was the salvage of this existing historic facade that you see, and the rear portion of the building that we'll see here. We had to make a physical separation between the two structures, and with the first building obviously to stay in place, and this it was called the gymnasium structure, to come down to make way for a new building that's going to be used by the St. Johnsbury community for I think it's a public service, the fire, police department, and 911 housing for the space, the footprint that's going to be exposed. Okay, Jennifer. We had a very, very good and extensive hazardous material survey for this building prior to the start of work. The city of St. Johnsbury had received very substantial EPA and state brownfields funding and for this project. And over the course of really many, many years of development, they used those funds to carefully identify hazardous materials within the building. And as we'll see, we had asbestos, we had hazardous materials, we had PCBs everywhere. And you can flip through a little bit, Jennifer, maybe one more. And we can see that this typifies the separation that we had to make between the buildings, so that the building in the center picture on the left of the separation is going to stay, and on the right of the separation would be taken down. But everything was PCB contaminated, either with paint, with caulking, with spill material in some cases. We found, and it was established, there were 10 identified waste streams. And our task became to very carefully identify and if you will, to use the analogy, source segregate those materials so that we did not commingle different PCB and hazmat waste streams. We kept them separate. We kept them minimized in that each one of these has vastly different disposal costs. And it became our function to do this as economically as possible through source separation, identification of the waste streams. We found one of the most difficult or time-consuming aspects of this is to get approval at disposal facilities for each of these waste streams. And it's a very complicated, time-consuming project, but overall, we were able to offer the owner, the city of St. Johnsbury, a very substantial value engineering savings of, I think it was over $100,000 by doing this, by separating the waste streams and not commingling everything as hazardous material going to a landfill in Wayne, Michigan. So, Jennifer, if you move, as I said, we had contamination. We had 10 different types of contamination, and we had 10 different criteria we had to follow at all these different landfills and disposal facilities. It became understanding the regulations and the disposal parameters of each of the landfills was essential to identifying where everything would go and why we were, collecting materials in some cases 10-ton lots to separate it from, say, to separate item number 7 from number 8, there could have been $150 or $200 a ton difference in disposal cost. So it was very, very important to maintain that vigilance and have your heads up all the time about how to do that with a brownfield site that's highly contaminated. Okay, Jennifer. Some of the ways we did that, you can look in here. Each of these pictures identifies sort of a different waste stream. The one on top, the green wall with the X's, I believe was one of the forms of PCB contamination that was in the paint of the material. And that is a different waste stream than what's that tan color right to the left of it. And then down the bottom where Jennifer is now, that was an asbestos containing plaster material with PCB paint. And this other section is some PCB and mixed asbestos and PCB material. They all have and had different designations, different characteristics, and went to different disposal sites under separate waste codes. Okay, Jennifer. Again, it was identifying 10 different streams and conducting your work as it went along, and we had some changes along the way. One of the things we thought was the slate roof we thought would go as a clean to an asphalt, brick, and concrete processing plant for recovery. But we found out there was PCB containing asbestos glue daubs that held the mastic, that were mastic to hold slates down. All that had to go out as a mixed PCB asbestos waste stream. You see on the exterior of the building some of the areas that had caulking, and around the windows caulking that was high PCB content and was segregated and treated that way from any other building material. Okay, Jen. So similarities that you might see, you might recognize the one of our high reach excavators with a rotating demolition tool on the end of it that we use on this building, like we used on the South Boston building to sort and segregate material. That follows our theory and our work plan to have the equipment versatile in multi dimensions. You also see careful separation of materials for source separation, in this case, different very restricted waste streams and waste categories and disposal sites. So some of the same principles that we followed throughout the other job, and we enact through every project that we do. We're certainly in play here. And I hope you enjoyed that. It gives you a little insight into some of the brownfields issues that you all face in your properties throughout your regions. And there are certainly many different ways to look at a project and to try to fine tune it. My take back from St. Johnsbury was the amount of time and effort that was spent on pre-testing. And I know it's very, very expensive, and sometimes easier to throw in the towel and say, hey, everything will go out as PCBs or asbestos. But you can work with a contractor to try to find a better solution. And I'd certainly offer that to anybody that, if you want to call me for any reason, would be happy to do that. But it's well worth researching these things because some substantial money can be saved in the way a project is executed. So Jennifer, thank you for inviting me. I hope everybody enjoyed the presentation. If there's any questions, I'm more than happy to see if I can answer them.
Great. Well, thank you, Dan. Yeah, I think everybody should just know, I think the big problem in St. Johnsbury was they just found this PCB contaminated paint and PCB materials almost everywhere, which is somewhat unique to that part of Vermont, I think, in that certain time frame that those things were used. So it really just
You know what, it
created.
was over the years we found out, Jennifer, it probably wasn't from the initial, some of it might have been initial, but I think it was subsequent over the lifetime, 100
Right.
years of that building, that layer upon layer just got
Yeah.
added that wouldn't have been
So it
contemplated.
just made it kind of impossible for Dan to do his salvaging type of work there, unfortunately,
And had to
because
dispose of the steel that normally we're able to recover and recycle. It was PCB contaminated, and we didn't have any choice but to cut it into very, very small pieces and bring it to the landfill for disposal.
yeah. So that's unfortunate. So thank you, Dan, for sharing your experience with us. And then also Danny and Megan, we have a couple of questions that go back to your presentations too. So you could unmute yourselves. And so Megan, someone is wondering whether the Phoenix case study that you mentioned sort of right at the beginning of your presentation would be, do you have a link to that? Is that included in the links that you have in your presentation, or could that be shared separately?
Yeah, that's a good question. I actually linked to an article that talks about the hub, and just due to the time constraints, I didn't have time to learn about the project, but I'm digging into it. So if the person with a question wants to reach out to me, I will share the information with them, because I'm also interested in learning more.
Okay. Let's see. We've got one for Danny. Where were you so you took the house apart in chunks, and then where were those chunks stored? Like what kind of process would be, for an average project be able to do?
Yep. So again, that project happened when I was still teaching at the high school. So I was being pretty scrappy and figuring out the logistics of that. Different situation now that I've started a company. I have I'm working actually out of an old Agway building. So I have a workshop in there, and I have space outside to store materials. But for that particular project, one of my students, who is a senior, his father owned Yachting Solutions, which is a yacht storage space that's very close to the high school. And he was very happy about what the program was doing. So he let us just kind of consolidate everything there. And it was really easy to bring sections over to the high school and deconstruct them outside just as we needed. And we did that over the course of a few months. We could have done it faster, but again, it was, when I was working at a high school and kind of doing this, almost as a side project. So that's where it was for that one.
Okay.
Dan, just a question. Do you have to do, when you do a building like that with the clapboard removal, do you do monitoring on your personnel for lead exposure? I know we do entry and exit blood levels, and we maintain a library of those exposure events.
Yep. Yeah, lead testing. And I can tell you, I haven't been doing this work for as long as some of the folks that I mentioned in my presentation, but Michael Gaynor, who's been doing this for now like 15 years, he's taken hundreds of structures down. He tested himself for lead at the beginning, and his and it has not gone up since he's done it. So he yeah, as an example of like, as long as you're following all the protocols and doing things safely, yeah,
Right.
you can do it
Well, that's
without exposure.
the work of protection.
Absolutely. Yep.
Okay. I guess this one would be good for Danny too. Because you mentioned like the gym and salvaging the flooring. Publicly owned structures, if you're going to deconstruct and salvage from those, have there been challenges with the reuse of that material because it was publicly owned or government owned, or how were those issues overcome?
Yeah, that's a great question. So I have not personally had to deal with that yet. But in terms of the public schools that I did under Michael's company, he worked directly with the flooring contractors that were, going to have subcontractors come in and do the demo work. So we came in and did those, and I could ask him and see how he managed that. I also mentioned that our public school needed the floor replaced, and that was the first time where I had to deal with a lot of these kinds of bureaucratic issues that were certainly, because I was trying to convince the administration to let us deconstruct it and save the material. There's a lot of memories on that gym floor, and we thought maybe we could make a bunch of products like desks and things to raise money for the school. But some of the barriers that we ran into were like, the insurance company needs proof of disposal. And I'm sure we could have worked through that, but that was like one sort of weird thing that we would have had to deal with. And then also just the contractors thinking we would slow down their schedule if we deconstructed it, where, again, I having done this, discovered that doing deconstruction the way Michael had shown me was way faster than doing demolition. And I recorded how that was demolished, and it took them, like I said, a week and a half, whereas I probably could have done it in a couple days.
Wow. Okay. We've got another couple minutes. If anybody has any other questions, there haven't been too many coming in here. So
usually in a case like that, that would be part of a bid process, the removal of the floor, whether it be in Danny's place, part of a flooring contractor's responsibility or part of another general contractor portion of the bid, but it would be bid out, and obviously if you can present a bid through recovery of the material that's lower than the alternative, then you have a job.
right. So Dan Costello is saying it should be part of the bid process, which is something I guess Megan is working on for the state of Maine in terms of their the way they do business, and even trying to emphasize deconstruction in a project for the bid, like
Right.
part of the bid
Well,
documents.
It's definitely aspirational at this point. We have some goals in our climate plan, and are looking to establish more sustainable procurement policies. So we have a long way to go too, but at least we're looking at it.
So here's a last question that everybody can maybe opine on, but particularly Dan Costello. How do you encourage and convince people to commit to deconstruction when it might cost more, or does it cost more? And are there any grant programs to try to offset it, or does it cost more?
Well, the grant programs necessarily, we're obviously, we know there are a lot of items that are highly valuable. Those timbers that you saw as an example is something that we've perfected in being able to recover, but we also have outlets for it. Actually, all over the world, we have outlets that will buy those timbers. Some of the other materials in a building, they're of such low value that we can't afford to salvage them. Smaller dimensional wood, even windows and things that might have a high labor cost to handle and package and deliver. We're union contractors, and the wage rate for those laborers is very high and often isn't absorbed by the salvage value that we recover. So we're sort of selective and grab, I don't know if it's exactly low hanging fruit, but certainly material that is substantial and able to be recovered. One quick story, I showed a picture earlier of a water tower in Reading, Massachusetts that was taken down, and you saw that it was on a set of 8 steel legs. Well, we salvaged those legs, and we sold trailer after trailer load of them up to northern Quebec to go into a mine for a shoring project. And we had a number of them in our yard, and a lady from Cambridge came in that's involved with the city and involved with design for deconstruction and using salvaged and recovered materials to build a building. And she came in probably last fall and saw those beams, and she designed a building around it. So we have them going to a new life from the legs of a water tower in Reading to an open pavilion building in Cambridge. So that's sort of a nice story.
Yes, great. Well, we are after 3, and I just realized I'm supposed to be in a different meeting starting now. So I think we're going to have to end here, but I really want to thank everybody. I mean, I think one last thing for the encouraging and convincing people is you also need a little bit more time often for deconstruction. So that can be a bit of a challenge too. But hopefully people feel the value of trying to do the right thing. might help there. So anyway, with that, thank you so much, Megan. Thank you so much, Danny. Thank you so much, Dan, for this today. I will be posting PDF of the presentations sometime in the next few days, and when that's done, I will send a link around to everybody that was on today. So thank you again to everybody, and I hope everyone enjoys the rest of their day.
Thank you.
Thanks,
Yes.
Jennifer.
Thank you,
Thanks,
Jennifer.
everyone.
Thank you. Bye-bye.